In this lesson, we're going to review what we did in class today, simplifying square roots, and then later on, rationalize the denominator. This is just a simple explanation, or I should say re-explanation, of what we did in class. I'm not going to get too much into the concept of it, but I am going to give you enough of the concept so that you can complete your homework and understand why you're doing what you're doing. So if you remember in class, we had something like the square root of 50. The first question I asked you was, what is the perfect square factor of 50? What is the perfect square factor of 50? And most of you guys came up with 25. 25 goes into 50, it's a factor of 50, and when you have 25, that's equal to 5 times 5. So if you take the square root of 25, the square root of 25 is a whole number 5. What we used this in was, instead of writing 50, we wrote the 50 as a factor pair of 2 times 25, and then we looked at how to solve it completely. Using the square root, we have 2 times 25. If we take the square root of 25, that's 5. And then we want to leave the square root of 2 as a square root of 2 because 2 is not a perfect square and it's not a whole number. We're looking for a nice, clean way to emphasize or to represent the square root of 50 without using decimals. And so then this is how we have to do it, simplifying the square roots. Here's a couple other examples that we looked at. I think in block C we looked at radical 60, block B as well. I think in block C we didn't look at radical 80, but I'll show you what we're going to do with that. So once again, the question that you want to ask is, what is the perfect square factor of 60? A perfect square factor of 60 is 4. Now I know that most of you guys would think, oh, 60 is equal to 2 times 30, or 6 times 10. But the problem with using one of the factor pairs of 2 times 30 or 6 times 10 is that neither 2, 36, nor 10 are perfect squares. So it actually doesn't help us simplify the square root. In order to simplify the square root, we need to have a perfect square in order to get one of the factors as a whole number. And so instead, we can think of, okay, if we use the 2, if we think 2 times 30, there is a 2 in the 13. If we move one of the factors of 30, which is a 2, into the 2, then we get 4 times 15. Now what's important to note here is that the 4 is a perfect square factor if we square each number. 15 is not a perfect square factor, nor does it have any perfect square factors, and so we get that radical 60 is 2 radical 15. Let's see how this looks for 80. Because instead of saying what is the perfect square factor of 60, for example, we're going to actually say, okay, what's the perfect square factor of 80? Well, there's actually two. 80 is 2 times 20, no perfect squares. Sorry, 2 times 40. Oh my goodness. 4 times 20 and 16 times 5. Now, both of these factor pairs have a perfect square factor. 4, 16. So, which one do we choose? Which one is the better one and gives us a more efficient way to simplify? I claim 16 times 5 will give us a more efficient way to simplify this. Let me show you why. If we choose 4 times 20 to represent the square root of 80, we get the square root of 4, which is 2, and then we get the square root of 20. But in the square root of 20, that's actually 4 times 5. So it's like we have to do this simplification twice, and then we have to multiply, and then we finally get 4 times radical 5. Now, if we actually use, instead of the square root of 80, we say that the square root of 80 is the square root of 16 times 5. Then we take the square root of 16, which is 4, and the square root of 5. We get the same result, but in less steps. Let me show you that whole thing of the square root of 80 and simplifying it using 16 and 5 as your factor pair. Much more efficient than using the square root of 4 times 20. Next, let's look at rationalizing the denominator. I had a few examples on the board, but this was my simplest one. The whole concept of rationalizing a denominator is we want to make this denominator, we want to make the denominator a whole number. And the reason why we do that is historically, when you're solving this problem and you have to evaluate it by hand, it's much more difficult to divide by a decimal than it is divide by a whole number. And so what you do is you multiply by radical 3 divided by radical 3, which gives a 1. It's not going to change the value, but it's going to change what the fraction looks like. It changes the denominator into a whole number, and this now is rational. Let's look and see the same method using 15 divided by radical 3. We're still going to multiply by radical 3 divided by radical 3, and we're still going to get a whole number denominator. But this time we can actually simplify the 15 and the 3 to be 5 radical 3. So make sure you just you continue simplifying. Continue simplifying. Let's look at something else. If we have to multiply by a fraction with a that has a radical in the denominator, we want to go ahead and do the multiplication. And then we have a similar situation in the previous slide, where if we multiply by radical 15 divided by radical 15, we still have to simplify, and so this result is 2 radical 15.